In this video, we're going to look at topic 85, example 3, graph a function of the form ax plus b over cx plus d. What is the graph of the function f of x equals 2x plus 1 over 3x plus 4? So the first thing we're going to do is we're going to look for a vertical asymptote. And remember, to do that, we want to set the denominator equal to 0. So you do 3x minus 4 equals 0. Obviously, we're going to add 4 to both sides. So 3x equals 4, divided by 3, and x would be equal to 4/3. So at x equals 4/3, then the value of the denominator is 0, right? That means it's undefined. So there's going to be a vertical asymptote at 4/3. Let's put that in, let's highlight that in blue. After we have the vertical asymptote, and we'll graph that in a second, let's look for the horizontal asymptote. And for the horizontal asymptotes, we need to compare the degrees, right? So we're going to write the whole function out. I'm going to say f of x equals 2x plus 1 and 3x minus 4. We want to compare the degrees here. So the degrees are the same. That, if you want to remember from previous notes, that's case 3, where the degrees are the same for both the numerator and the denominator. That means our horizontal asymptote is the ratio of our leading coefficients. So that would be 2 and 3. So we have a horizontal asymptote at y equals 2/3. Not the friendliest asymptotes to graph, but we'll work with it. So we have that. All right, so let's plot those. So the vertical asymptote, I'm actually going to use, I'm going to highlight this here to make this a little bit thinner. Might be a little bit easier to see. So the vertical asymptote is 4/3, or that is the same as 1 and 1/3. So we're going to put that at a vertical asymptote about here. All right, now you'd use a dotted line normally. I just want to make it a little bit more visible. And then our horizontal asymptote, the same thing, or not the same thing, but we're looking, I'm going to use a highlighter again, 2/3. So that's going to be somewhere about here. Right? We don't need this to be completely perfect. We're drawing a sketch. And now we have our vertical and horizontal asymptotes. The only thing we need to do now is draw the rest of the function. So I'm going to use my graphing calculator to come up with some points. So my numerator is 2x plus 1. Make sure that goes in parentheses. And then we're going to divide. Again, use parentheses, 3x minus 4. And then if I hit graph, well, let's fix the zoom here. If I hit graph, I do get a graph with a vertical and horizontal asymptote that looks similar to what I have. So now I'm just going to come up with some points. So hit second table, second graph, and let's come up with some coordinate points. Let me just change this real quick. Sorry about that. From the previous problem, I forgot to reset it. And let's just start that at 1. There we go. Okay. So I'm going to go all the way back to -5 because that's where my graph starts. -5 is about half. So let's plot that. That'll be somewhere about here. -4, I don't really need a lot of these. Let's go with -2, 0.3. So that's going to be somewhere about here. You can plot every one of these, but we just need the shape of our graph. So 0, -0.25, that'll be about here. And then 1, -3. So that'll give me a good shape or a good curve for my graph. So draw my little arrows, connect my dots, and that looks good enough for me. On the right side, we're going to go to 2. We can actually, oh, we did use 1. So we can use 2, 2.5. So that would be about here. 3, 1.4. 4, 1.1. So we're just getting closer and closer to this, and 5, 1. Which makes sense, we're approaching that horizontal asymptote. Again, connect our dots, draw a curve as best we can, and we have our graph. So the ones that are in the form ax plus b over cx plus d are a little bit easier than some of the other ones we're going to get into, where we have to do some factoring. These ones, straightforward. Take your denominator, set it equal to 0, find your vertical asymptote. Take your whole function, compare the degree of the numerator to the denominator for the horizontal asymptotes, and you'll decide between case 1, case 2, and case 3. And you'll either have a horizontal asymptote at y equals 0, no horizontal asymptote at all, or it'll be the ratio of your leading coefficients, which was the case here. All right. I'm not going to talk anymore about this problem. We're just going to stop there.